SkySpark is an analytics platform that automatically analyzes data from automation systems, meters, sensors, and other smart devices in order to identify issues, faults, trends, correlations, and opportunities for operational improvements and cost reduction. SkySpark works with data of all types, whether it be live data from automation systems, smart meters, web services, or historical data from CSV files and databases. SkySpark can also be used in a wide variety of applications, including energy and resource management and reporting, monitoring-based commissioning, equipment fault detection, energy analysis, load profiling, facility benchmarking, and asset performance tracking. Visit skyfoundry.com today and start finding what matters.
Hello from Charlotte. My name is Mike Talbot, and I wanted to tell you how pleased I am to present to this conference. Having been a commissioning agent for over 30 years, one of my biggest frustrations has been filling the gap between the commissioning process and turning the building over to the operation and maintenance staff, O&M. Hopefully this seminar will give you some pointers on how to fill this gap. As noted, this course is eligible for a PDAH. Please request a certificate if needed. If you want to copy any of these materials, just send me an email. I'll be glad to oblige you. The course description sets a successful commissioning, retro-commissioning process ensures not only that the building operates as the owner intended, but the building staff are prepared to operate and maintain the systems and equipment as intended. Communication is the key to any relationship. It is the commissioning agent's responsibility to make sure the designer's intent for operations and maintenance is adequately and thoroughly communicated properly. The learning objectives of this seminar are: number one, understand the differences between building maintenance and commissioning. Number two, how to maintain building performance after the commissioning process has ended. Number three, understand the important roles that the O&M staff have during the commissioning process. And number four, review the O&M best practices for energy efficient buildings. A little bit about myself. I graduated from NC State in 1982. Some of my design projects, I did the most energy efficient building at Clemson University, what's called Lee Hall. I designed the first LEED Gold project in the state of South Carolina, and I designed the first LEED Platinum maintenance facility in the United States. And this past year, I was nominated as an ASHRAE Fellow. In order to develop a successful operation and maintenance program, it is essential to get to know the people who will be operating and maintaining the building. And like with any relationship, you have to get to know the O&M staff early on. What are their education? What's their current and prior work experience? Whether their likes and dislikes, for instance, if they like train versus JCI. And are there any non-negotiables? What specific control vendors that we must work with during the design and commissioning process? And also financial, what bells and whistles do you want incorporated into the control and commissioning specifications? And if you do all this, you'll end up with an O&M staff that loves to operate and maintain their building. So operations and maintenance are integral with each other. You can operate a building well and not maintain it, and it will be a failure. You can also maintain a building well and not operate it correctly, and it will also be a failure. Who makes sure that both things happen? So let's discuss the different types of maintenance. The first is what I would call reactive maintenance. Fix it when it breaks, basically. And you may have a scheduled filter change out. The next best maintenance is called preventative maintenance, which occurs at time intervals or run hour milestones, and it focuses on the components of the system, which include cleaning coils, changing filters, tightening belts, and calibrating sensors. But the problem with preventive maintenance is the staff is typically short-staffed, and they're trying to deal with nuisance problems and complaints, and sometimes the preventive maintenance is put off. The other, last but not least, maintenance is called predictive maintenance, which uses periodic or ongoing measurements to detect evidence that the machinery is deteriorating. So an example of this, rather than change filters out every 3 months, you put in a program that changes the filters out when the static pressure drop exceeds a certain level, and then you automatically create a work order to change the filters. Quality maintenance is published by ASHRAE Standard 180, and basically it's maintenance requirements that preserve a system's ability to achieve acceptable thermal comfort, energy efficiency, and indoor air quality. And the responsible party, of course, is a building owner or designated other parties that shall be authorized and contractually obligated to fill the owner's responsibility. The maintenance program is developed first by taking an inventory of the items to be inspected and maintained, and then you start your maintenance plan development. You come up with performance objectives, condition indicators, inspection and maintenance tasks, and inspection and maintenance task frequencies. And then you should document it, listing the systems and components, the inspection and maintenance tasks and method of tracking, whether it be automated or manual, sufficient record detail and verification, written or electronic, and then emergency information that would be required. Then you, of course, authorize the maintenance plan and execution, and then you make any revisions to the maintenance program as you develop it. So one thing I've seen over the years are maintenance budgets are being reduced like everything else in life. So we would see a predictive maintenance go into a preventative maintenance and then go to a reactive maintenance. And what I see is deferred maintenance costs are rolled over into capital construction budgets. Example of this is a real life example. There was some deferred maintenance on fan coil units for an entire building, and the owner wanted us to put in the contract documents the deferred maintenance items, even though we were just renovating a small portion of the building. So we put these notes on the drawing, flush out the entire hot and cold water piping system, blow down all the strainers, replace all the filters, clean all the coils, and then clean all the exterior cabinets. And this was to be done by the contractor for a capital renovation project. So initially the labor cost would be $90,000, whether it be done by the contractor or done by a maintenance person. Labor burden was $27,000. This was a VA project, so VA set aside was $9,000 with a subtotal of $126,000, bond at 3%, profit at 15%. So your $90,000 maintenance cost was ballooned to $188,000, which is double what it would have cost you if you had your own man do the maintenance. So think of this, if you could possibly move capital budget costs over into your operating budget, you could buy a $90,000 maintenance man to do the work that you need to have done. Now I'm going to talk about how to develop a training plan, which is very important to develop a training plan early on. Again, you want to take a skills inventory of the current staff, examine the building operations and maintenance goals, take the employees' input, and then you craft a plan together. And again, in my opinion, this should be done by the commissioning agent. So there's several types of learners: visual learners, auditory learners, and then of course there's kinesthetic, tactile learners, which most people fall into this category. These people like to be hands-on and like to be involved with the physical environment around them. These learners need motion to learn and enjoy moving and activities that allow them to touch and manipulate things. So during the pre-design, we go back to the introduction of the O&M staff. You set the format and begin to implement and determine the champion for the training plan. And I think this again should be the commissioning agent. During the design phase, you develop the training plan, either standalone or defined section of the commissioning plan. It lays out the training needs and expectations, lists training requirements, who's the intended audience, suggests venue approach, and estimates time allocations. During the design phase, you also outline the training verification requirements. It must be detailed enough to permit reasonable bidding and scheduling by the contractor, and will likely involve involvement by the design team members. The commissioning agent verifies that a sample of the training activities meets quality expectations and conforms with owner project requirements and contract documents. The verification process is looking for systemic problems. Lack of performance should not be tolerated and should have consequences. Doing something instead of doing the right thing is just covering up the problem, often leading to setbacks. Any minor deviations would be addressed via the issues log. Major deviations might require concerted action from the commissioning team. The owner retains ultimate acceptance responsibility for deviations that negatively impact the OPR. And obviously, during occupancy and operations, you verify acceptance and incorporate into the systems manual. Also, as part of the training, we like to provide training videos, and these videos can be produced at the time of commissioning. And I would suggest having a professional to produce and edit the videos, although I've actually had videos taken from my iPhone as part of the commissioning process. The videos can be made part of the commissioning specification, and after the videos are completed, they're available to all operations employees. Another thing we like to include is 3D renderings as part of the training manual. This is a 3D rendering we did for a RO system and domestic water system, which shows all the building, the equipment for the RO system, for the hot water, and for the water softening, how the sinks are connected, etc., so that a building owner or operator can readily see the interconnection between the equipment and how it ties together versus having to read a plan. So I want to talk about monitoring-based retro-commissioning. And retro-commissioning is a process to improve the efficiency of an existing building's equipment and systems. It can often resolve problems that occurred during the design phase or construction, or address problems that have developed throughout the building's life as equipment has aged or as building usage has changed. Monitoring-based commissioning is a process of collecting, storing, analyzing, and reporting data collected through sensors to optimize equipment performance and efficiency. Monitoring-based commissioning is a way to maintain and continuously improve building performance over time. The old way to operate buildings, you either get complaints, alarms, or you do physical inspection, and this is troubleshooted by facility staff and developing work orders to maintain the equipment. And basically, under this scenario, one facility manager can serve up to 200,000 square feet of building. The new technology assisted way to operate buildings, you use data. You use HVAC trend data, sub-metering data, utility bill data, weather data, benchmarking data, equipment data, metadata, and still occupant complaints. You use analytics and fault detection to develop faults, key performance indicators, and also visualizations, which are then evaluated by expert. Then the work orders are developed by the expert, and then the feedback and validation is given back to the system. And the good thing about this is one systems expert can serve up to 20 million square feet. So this concludes my presentation. If you have any questions, please feel free to email me or call me on my mobile phone. I'll be here, glad to help, and I appreciate any opinions or feedback that you would have for this presentation. Thank you again, and have a good day.